Okay, so this type of window will appear in front of you. Now I hope that most of you have installed the SAP. Okay, start it. Sorry? Okay, put it over there. Just focus the screen, that's all.
You should set this so it will not be.
Okay.
You can
Okay, please do not sleep, okay? Because there are no lights in the class, so most of the students take this as an opportunity to sleep. Okay, so first of all, we will go to the new model, and here you can see different types of options. For example, if you are using E-tabs, in case of E-tab, you will be having different types of slab system, like slab with perimeter beams, slab with baffle slab, slab without beams, flat plate. But in this case, because SAP is a software which is basically used for the analysis of structures, it is not a building specialized software. That's why you will look these type of templates. Out of these templates, which one you would select? Please tell me. Yes, the grid only is the best option which we can have. The other one we can go for the blank. But as we have the grid dimensions, so we can go for the grid only, and you will see these type of things. Now, if you see the grid spacing, it is coming out to be 288. Now the next question should be in your mind, what is this 288? You should, exactly the same time, you should must look it over here. What is here? Kip inch. It means that all your length dimensions are in inch. So what is this 288? Inch. So if you are using FPS system, like the strength in PSI, the steel strength in KSI, okay, the load in pound, so maybe you can move with the same system, kip inch. But as we are following the SI system, which is basically Newton millimeter, kilonewton millimeter, kilonewton meter, so any one of these units you can select the most convenient units of your own choice. What would you prefer? Anyone, like, and these units you can change at any time. For example, if you want to put the load, you should put in kilonewton, or you can put in kg, up to you. But if you are going to put the material strength like Fc prime and Fy, you can put in Newton per millimeter, like megapascal. Okay, let's go with Newton millimeter. Okay, now again, file, new model, and grid only. How many grids for your model in X direction? Please tell me. So, in X direction, you have 5 grids. Or if you want to add the grid for the cantilever, it's up to you. For example, if you want to add a grid for cantilever, you can add it. But if you don't want, okay, no problem. For example, in X direction, I add like 6 grids. I am going to add the grid for the cantilever. It will be 7. And then in Y direction, how many? You can keep it 4. In this direction, okay, I don't add the grid for the cantilever. Keep it 4. And Z direction, how many number of stories? 4. So 5 grids. Now in this direction, because it is a template and you must have to give the constant spacing between the grids. But later on we can change them. So how much you want to give? Okay, 6,000. In Y direction 6, and in Z direction
3 into 4.
Okay, the first story and the second story height is 4 meter, and the third and fourth story height is 3 meter or 3.5 meter. Okay, we move with the all 3500 and make it okay. So this is going to be the first layout which you would see. Okay, now you can edit these grids. I told you you can right click. Please see again, if you right click over here, you will see this edit grid data, and if you click this edit grid data, this type of box will appear in front of you. Over here, just click modify and show system, and once you will click, all these grids which you have defined at the beginning of your modeling will appear in front of you. What are these ordinates? These ordinates are basically the distances from the origin in X direction. What are these Y grid data? These are the ordinates from origin in the Y direction, and Z direction is basically the vertical direction. Okay. Now, for example, the B ordinate, you want to change it. For example, how much should be the B grid for your case? It is these are the basically you can also see these grids, the very small layout on the right side of this window here. This is A, this is B, C, D, E, F and G. So how much is distance between A and B? I mean, what should be the ordinate for B?
7.
No. No. It is 1000. It is for the cantilever. And what about C? 6000 plus 1. That's why I ask you to remember that.
We can't choose the spacing.
Spacing choice.
Okay, now we are moving with this. You can choose the spacing. Okay, it is basically not 6, it is basically 7. So this will be 8. 8000, and then add 5000 in this. 13,000, and then add further 18,000, and then 7,000. Again 7,000, so it will become, and then add 1,000, now just see this shape. Is it becoming similar to what you have decided? Now in this direction the first was 6,000, and now these are the ordinates from this point. From this point, please see see the mouse. From this point. So how much was this? It was 6,000.
Yes.
And then this was 4.5 meter. Now for example, you can select spacing here. If you click here spacing, you can see the spacing, and if you click over here the ordinates, you can see the ordinates. Now for this is grade 2. For grade 2 you can give okay, and for the grade 3 you can add 4500 into 6000. It will become, and This is add again 6 meter into this, it will become
16.5.
okay. Now you can see it is also adjusted. Now come to the story data. For example, we decided that the first 2-story height would be 4,000. Second story you can, okay, from second to third we keep 3,500. Oh, sorry, these. Let's see what happens.
Should we consider the depth of slab?
Dead load of slab, depth of slab, actually these are the center to center heights. You can calculate. For example, if you in the drawings you have the clear height. For example, the height from the, that is known as ceiling height, which is the height from the slab to the floor. So if that is the case, you must have to add the slab depth into the ceiling height to get the center to center height. Okay, and then you can make it okay, which is somewhere hidden or down.
The start menu, you can move right. Right click on the start menu and you can drag right.
Now,
There's click right.
actually, you know what is the problem? It is in Japanese. So,
Click right on the start menu and make.
now I hope you understand.
I'm not doctor, I can move it. Yes, press enter. This is one of it.
Wait. Okay, no problem. Wait. I do it again. Actually, maybe this problem won't be in your computers. For this case, sometimes the diode size is very big.
Doctor, take out and do something. When you finish, take out.
Alt. 1,000, 8,000. It was 5 meter, 13. 18 and
not spacing. Not spacing.
now 5, 5, 7. 7 is okay, and then this was okay, 6,000, 10,500. Okay. Okay. Now,
Doctor, take out the VGA.
let me change the view. Control Alt.
Doctor, take out the VGA. Listen. I'll check that.
Okay. Please click. Please see, this is the plan of your building. So now these are the grades. But 14,000, 0. Wait. Okay, before we proceed further, we must have to store it. Save. Okay, now this is 4,000, 8,000, 11, 15,000, and that's all. Now please see this thing. Now how you can change? You can change from, now basically SAP have file, edit, view, define, bridge, these type of menu bars you can see at the top, and at the bottom of that you can also see these two toolbars. So these toolbars, you can see this tool move up in the list. You can use this tool to move up the whole plan. For example, there are two views of the SAP. The one is XY plane and the other is 3D view. Please see mouse, don't see me. This is XY plane and this is the 3D view. Now, for example, you can see from the 3D view that this colored line is showing you the elevation or the location where you are basically observing the plane, XY plane, and how you can move this plane by this option. Move up. Now it is the next story level, next, and this is the foundation, you can say, 0 level, and this is the first story level. So where you will model the first floor, you will model the first floor over here at 0 elevation or at 4,000. 0 elevation. Where will be the beams for your building? Of course at 4,000. At elevation 0, we have to provide the supporting system. Now please see, this is the first step, edit grid data. Now the second step is draw beams and columns. Now you have two options. Number one, you can draw any size of beam and any size of column, and later on you assign the size which you are going to provide. You understand? For example, for our columns we have like 450 and 450, 300 and 300, and same for the beams. But if you say no, I want to draw the same beam and same column which I have decided, then you have to go to the define. So how you would like to proceed? Please tell me. First you want to draw the beams and columns of any size, or you want to draw the beam and column of your defined size? Okay, now leave all the things and come to the command define. This command. Now we will finish this command and then we will move further. Okay, today we are going to do only the define command. Now, I know. Now, number one is materials. Okay, how many materials? We have two types of concrete materials, 30 and 21. So, now you can, for example, there are two materials, 4000 psi, it seems that it is a concrete, and this A9925Y F yield is 50 ksi, it seems to be steel. But if you want to copy these two materials and you want to use the properties of these two materials, you can use it. But please make sure what are the units. Before assigning the material properties, please make sure what are the Newton millimeter. Okay, now let's add new material. Now what material you want to add? Concrete? Okay. Now give here the material name. 30. Is it okay? Or if you want to add okay. Now this is the weight per unit volume. Oh my God. Now it is weight per unit volume. What is mass per unit volume? Density. Now it is, now this value is for the steel. This value is for the, for concrete, how much is the density? 2400 kg per cubic meter. And how much will be the unit weight? Yes. Now, but you need in Newton millimeter. Check if it is okay or not. Please check. E 10 raised to the power minus 5. This E means 10 raised to the power minus 5. 2.4 into 10 raised to the power minus 5. And modulus of elasticity. How you will give this modulus? E. No. That is 200 gigapascal for steel. Now you have to give it 4700 under root FC prime. Please remember the formula. Calculate it. 4700 under root FC prime. Please select. Calculate.
4700 under root
FC prime. Please, these steps you have to do. If you do mistakes in these, I will take your marks.
2000.
Now please see how I am going to put these values. E.
Like this.
25.
Almost. Even the table.
Please, you have to put the value of, it is 4700 then into under root FC prime. FC prime is 25. Okay, make it 3. point ratio for concrete. It varies from 0.15 to 0.2. Coefficient of thermal expansion. Again, you have to find out this value from the core or from any. For example, so from here you can select any suitable value, but in very important projects these values are given by the clients. Okay. For example, for different materials you can see here, and for concrete, please see it is in Kelvin system. Yes. So concrete, where is concrete? And other is degree centigrade. R is degree. So we are basically following the degree C. So it will be 8. 8 into 10 to the power minus whatever it is. Inch over inch cancel. 10 minus 6. So keep in your mind. And this is the most important thing. It is the specified concrete compressive strength FC prime. So what you will put here? And make it okay. Now this material is over here. Now you can add copy of this material. So the same material properties which you have given will come over here again, and give FC 20 and again calculate E. It is 4700 under root FC prime. 21019 and change. Okay. Finish. Now materials. Now these two materials are already there. For example, if you have more materials, you can add more materials. Okay. So this is the part 1 of our lecture. I am going to stop my class over here, and we will still continue with the same define command. And the next class I will tell you how you can define slab, beam, column and wall. Okay. And at the end, the most important thing, load. For example, in the section properties we will define frame, area, and then we will go for the load patterns. This is the load patterns are this define command is very important. Your 20% of work will be here, 20 to 25%. Okay. So I just saved your model here. Keep all the data with you, and inshallah we will continue from the next class. And today I need the groups. Please write your group in email and email me by today. Okay.
Do we need to provide grades for